And I'm sorry, I just want to make sure that was part of you kicking things off. With the quadratics, you have a little bit more work to. This first one is pretty standard, and it would probably be best to think maybe table or transformations if you want to plot a few points. But the thing you're going to have to come up with is the vertex, y-intercept, and zeros, which would be like x-intercepts is another word for zeros. And the quick way to take this one on, I'm going to talk transformations. I think you guys can handle it. Let's say what we know. We know y equals x squared is this nice little graph. Okay, and y equals x squared, like this, is has special points on it that you want to take note of. They go through and make a little table of that. And y equals x squared, when you put in 1 for x, remember you square it and you get out 1. And then if you put in 2 for x, so if this is 1, this is 2, and you square it, it goes to 4, correct? Because you're squaring that, whatever x is. So the points that you get on the regular graph are 1, 1, and 2, 4, and negative 1, 1, and negative 2, 4. That's a regular old x squared graph. But what's happening, you might not remember, but this negative is what we call a vertical flip. A vertical flip. And then this little plus 2 right there is shift up 2. Takes the graph and shifts it up to 2. So it takes this graph that I already know, and so here's the origin if you couldn't see it on your graph. It's right there. And if that's where the regular graph is, if I do like my regular x squared graph is in blue here, and I go over 1, up 1, and over 2, up 4, this would be the graph. And you don't necessarily have to draw this, but I wanted you to see that's the normal x squared graph in blue. In red here, I'm going to put in the transformed one, the one that we're supposed to be drawing, negative x squared plus 2. But those are, if you get the idea, we're just going to mess with that original graph. We're going to vertically flip it upside down. And if you want to do that with me, you can in steps. It means turn it upside down. So it goes down this way. Instead of over 1, up 1, we're going to over 1, down 1, and over 2, down 4. So you get the same shape, same spacing, same gaps between the points for this, but it's just being flipped upside down. And you did a little transformations in Algebra 2, and you do them a little bit maybe in trig with some moving trig functions around. So if that's familiar, that's the vertical flip stuff. Boom, check, we just took it on. But when you go up 2 is you take the whole thing and you slide it up 2. Yeah, let's go, I don't know, purple. That'll stand out a little bit better. But to go up 2, you take every single point, move them up 2. So this whole graph just slides up 2. And you can kind of actually just make your new point there and then go over 1, down 1. It's the same over 2, down 4. It maintains its structure. We haven't stretched it or pulled it in any way. That comes later. We do that too. But that graph is an upside down parabola that shifted up 2. And that's just me noticing the transformations on a graph that I know. And by the way, knowing these 1, 2, 3, 4, basically 5 points of y equals x squared becomes essential as we move forward. It goes through the origin 0, 0, and then over 1, up 1, because you're squaring it, and over 2, up 4, because 2 squared is 4. If you go over 3, it'd be up 9 if you wanted to go that far, but you don't need to. Okay, that helps because that's actually where the rest of this ends up taking us. So knowing that little bit of transformation on the first one, we're going to use that technique actually on the second one. You might have ways for graphing this. Of course, our graphing calculator, now you know how that works. You could definitely do that. But instead, we're going to do something called completing the square. And I'll show it to you today and know that we'll see it again on Monday, but you want to take some time to navigate this a little bit. It's on your online homework too, so you'll see it pop up. And you can always Google completing the square videos beyond mine if you want, because it takes a little while to nail this down. But here's how it goes. You group x's and y's when you're completing the square. You group your variables. That's the first part. So here I am grouping my variables. And that means, watch this, x squared minus 6x, I'm going to put in parentheses plus 3. And the grouped variables are where what we do what's called completing the square. Okay, so I group the variables first. And then after I do that, here's how the completing the square goes. You actually take, and if the coefficient on the x squared is 1, you're ready to start. If not, we would have to do some factoring here, but that comes in another problem. But this one's ready to go. You actually take half of that middle term, the b term, whatever's with x to the first power, we're going to take half of that, which is -3. It's a very important number. So half that middle term, and we're going to square it and add it to this, what's currently a binomial, this x squared thing. So -3 squared. And if this kind of like rings little bells, like you once saw this back in Algebra 2, that's plenty. This takes some practice, and once you get it, usually everybody comes to liking it. It just takes a little while. Okay. So I just took half the middle term, which is, when I say middle, I mean like the b term in the quadratic formula, and it's -3. I squared it and added it. Now this is in parentheses. This will always be a positive value, what I just added here, this little squared piece, okay? As you're squaring it, negative times negative is a positive. And I added it. And that's different from the +3 that I have outside. That's still there. I didn't get rid of that. But what happens now is, since I just squared and added basically 9 to this, you actually can't just randomly add 9 to an equation, right? You have to get, you're going to do it in the parentheses, you added 3 squared, but now on the outside you're going to subtract it back out because you don't want to actually change the values of your function, you just want to make it look different. Okay, so that's, you complete the square, but you compensate for it, and that's important too. So what we just did was we completed the square, which is half the middle term. We squared it and added it. So we complete the square. I can show you what that means on Monday, why it's called completing the square. And you compensate for that extra value. Compensate means basically subtract what you just added. You compensate for the new addition. Ta-da! Okay, so it looks funny. It looks like we haven't done anything yet, but here's the key. That little trinomial that I made, here comes Gramster, he's coming over to chat with us. This trinomial that I just created by taking half the middle term and squaring and add it, it's equal to a new form of it. It's actually the same as x, that half term, that -3, quantity squared. So, and by the way, remember this -3 plus 9, we're going to deal with that too. I'm sorry, +3 minus 9, that's going to make -6, right? So if you watch, there's those numbers made -6, and the stuff in that red box is equivalent to this expression. And that's a known thing. If you take half the middle term, square it, and add it, you are welcome to then rewrite that trinomial quadratic as x and the middle term, half the middle term, quantity squared, as I've written down here. So that's called completing the square. I'll write a little formula, like a generic formula. I sure hope that jogs in memory for you, because if it does, it seems more helpful. But just think of, I grouped x's, I took half the middle term, I squared it and added it. I can't just add numbers, so I also subtracted it on the outside, that same thing I just added.
I just know that. Fire.
We'll clean it up.
It's like a fire.
Yeah, I spilled some cereal like fire,
Dad,
but make sure you clean it up.
me?
Yep, just a second, buddy, I'll help you out. And then 3 take away 9 is -6. And that's it. Believe it or not, these 3 expressions, I'll star them. This one, and the very original one. They're all the same thing. They graph the same. They just look different. They have their advantages. So the bottom one, what's so nice about this new completed the square form, is that these two numbers, 3 and